Hey guys, today we're going to continue with your triangle congruence theorems, and we're going to learn about ASA, AAS, and HL. Okay, but before we do that, I want to review all of our different triangle congruence theorems and give you pictures to represent each before we do any examples. Okay, so you might want to find some blank space to where we can write some stuff down. Okay, so the first one I'm going to start with is called SSS, or side, side, side. Okay, what that means is you need to have two triangles, and in order for them to be congruent, you need to have three sets of different congruent sides for those triangles. Okay, so that is SSS, three sets of congruent sides. The second one is called SAS. Okay, and that means that you have to have two sets of congruent sides and one included angle. So if you had triangles, okay, for them to be congruent, you would have to have them have two sets of congruent sides. Okay, so two sets of congruent sides. Okay, and the included angle, or the one that both of the triangles have congruent, the angle, has to be in between those two. So for example, an included angle would be the angle that makes up those two sets of congruent sides. So you would have to make it look like this. Two sets of congruent sides and an included angle for SAS. Okay, the third type that we're going to learn today is called ASA. Okay, ASA, if you have two triangles, let me go ahead and draw those for you. Okay, to have ASA, you would have to have both sets of triangles have a congruent side and two angles. But the way this needs to look is that you have to have the congruent side, okay, and the two sets of congruent angles have to sandwich each side of that segment. Okay, so it would have to look like this. So you'll notice that you have the segment, okay, but then you must also have those two sets of congruent angles that make up the ends, okay, of that segment. Okay, so that's very important for ASA. Okay, all right, the next one is called AAS. Okay, and AAS stands for angle, side, angle. So if you have your triangles, there, you would need to have two sets of congruent angles, and you would have to have a congruent side that is not in between those angles. Okay, so for example, let's say you had two sets of congruent angles, okay, here, and these guys. Okay, well in ASA, you would want these this side to be congruent. Okay, but ASA is a little bit different than AAS. AAS requires that you have a side that is not an included side. Okay, so you could have a side that is congruent that's not in between those two angles. Okay, so make sure that you understand that AAS is the same as ASA, except you would not want to include that included side. Okay, and the last one is called HL, or hypotenuse leg. Okay, and what hypotenuse leg says is that two triangles are congruent. Let's go ahead and draw your triangles. If they have right angles, they have congruent hypotenuses, and they have one set of congruent sides somewhere else. So it could be here, or it could be another leg. So they have to have a congruent hypotenuse, and they have to have one other congruent set of sides. Okay, so make sure you have these 5 different things down, you will have to use them to identify if triangles are congruent or not. Okay, so let's go ahead and do a couple of examples here and determine if you can use certain congruence theorems on them. All right, so let's look at this first example. It says determine if you can use ASA to prove the triangle's congruent. And remember, ASA is when you have 2 sets of triangles. Let me pull it up here. And you have the 2 sets of congruent angles, and you have the congruent side in the middle of those 2. Okay, well, let's look at this triangle. Okay, you have 2 sets of congruent angles in both triangles, which is great, so you have that qualification set up. Okay, but the only place that you know you have a congruent side is right here. Okay, on these, you don't know if those are congruent. It doesn't tell you. Okay, and this is the segment that you would want to be congruent to be able to use ASA. Now, you can use AAS. Okay, so let me erase this. Okay, so if you erase this, you can see that it can use ASA, because ASA says that if you have 2 sets of congruent angles in each triangle and you have a congruent side somewhere else that's not in between them, that would suggest that we have ASA. Okay, so we have an angle and a side, or we have an angle and a side. Okay, let's try this one. You try number 1 here. We want to determine if we can use ASA on this one. Okay, so let's determine what we know about this. Okay, well, first, we know that in L, that segment is congruent, okay, by the reflexive property. Okay, so we also know that this angle is congruent to that angle by the alternate interior angles theorem. And likewise, we can determine that this angle and this angle are congruent because they are also alternate interior angles. Okay, and since you have 2 sets of congruent angles, and you have a congruent included side that's in between them, you can use ASA. Okay, so you just need to figure out what you know about the triangle and then determine if you can use that property effectively. All right, let's try another example. And we want to see if by AAS we can prove the triangle's congruent. So let's go ahead and mark what we know. Okay, it says that X, or angle X, is congruent to angle V. Okay, so let's go ahead and mark those. Okay, X is congruent to V. It also says that angle YZW is congruent to YWZ. So YZW is congruent to, what was that? YZW is congruent to YWZ. Okay, so those 2 are congruent. And we also know that the segment XY is congruent to VY. Okay, so let's look at these triangles here. Okay, and we want to know if XYZ is congruent to VYW. Okay, so basically we want to know if these 2 triangles can be determined congruent based on what we know. Alright, so let's think about this. Since we know that these 2 are congruent, we can then go ahead and assume that these 2 angles are congruent. Why? Because we can take whatever these guys are and subtract them from 180 and they're the same. Excuse me, whatever these angles are right here, hey, you can take that angle and subtract it from 180 and you would get these angles right here. And it would be the same on both sides, so you know that they are going to be congruent. Okay, so let's erase some stuff here. Seems like the eraser doesn't want to work. Okay, well anyway, we know that these guys right here are congruent. It's getting kind of messy. So we can see that we have two sets of congruent angles on these triangles. And we have a congruent side that is not in the middle of those. Okay, so we can, in fact, use AAS. Okay, remember AAS looks like this. Two sets of congruent sides, or congruent angles, and one congruent side that is not in the middle of those two. Okay? I know this is a lot of information, okay, but basically, if you can memorize these pictures, you'll be in good shape. Okay? All right, we have a couple more examples to look at, and then we'll be done. Okay, this one says that JL bisects KLM. Okay, so JL bisects KLM. So we know that it cuts through the middle of this big angle, so we know that these two little angles here would be congruent. And we also know that JL would be congruent on each side because they are congruent by the reflexive property. Now, since we have two sets of congruent angles on both triangles, here, 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 and here, and we have a congruent side that is not included, we can go ahead and say that this triangle is congruent by AAS. Okay, where you have two sets of congruent angles, but the side is not in the middle of those. Okay, so we would have congruent by angle, angle, side. Remember, those pictures are important to memorize. Okay, let's look at a little bit more. Okay, we want to determine if these things are congruent by the HL theorem. Okay. On this first one, let's see what we have. We have two triangles that have right angles, which is great. We have two triangles that have congruent hypotenuse. And we also know that they have one congruent side because this side is congruent by the reflexive property. So since you have all three of those things, you have congruent by HL. Okay, let's try one more, and then we will be done. Okay, on this one, we have two triangles that are right, which is step one. You have a side that is congruent on both, but we don't know if the hypotenuse is congruent. So for them to be HL, the hypotenuse must be congruent. Okay, so if the hypotenuse is congruent, then we would know that these two triangles are congruent by HL. Okay, so I know that this is a lot, and I know that it can be tough, okay, but if you memorize those pictures that I showed you on the previous page, you should be completely fine. Okay, I want you to try number 3 by yourself. See ya.